All right, we're taking a look at another geometric shape. We are going to return here, though, to one that we've seen before. We're going to look at the parabola, which we've seen when we discussed quadratic equations, like y equals x squared. So we learned all different things. So y equals x squared, we saw degree 2 on the x, and that told us that was the highest degree. We made this U shape that extended forever. We learned how to find the vertex. It was hk, if you remember this. We also learned that if y equaled negative x squared, if we had a negative out front, it would turn that parabola upside down. Now, we're going to work with this exact shape again, and there's going to be some similarities with what we did before, but we're going to learn how to define the parabola in some unique way, in a unique way that we haven't seen before, which is going to give us some more detailed information about it. So we're going to look at the standard form of a parabola, and that standard form has two possible equations. We have this one or this one. Now, this equation is going to be based on this idea of p, that there's some value that helps us define this. Now, as we get to this more advanced stuff, I don't have all of the proofs for why these equations work. I don't have them. I'm not sure if the book has it. This is not something I've used a great deal in higher math. It might be something you revisit in maybe even Calculus 2. You won't see it, I don't think, in Calculus 1. So I'm going to leave the proofs to the textbook, or to look at if look it up yourself if you're interested. I'm just going to dive right in with the formulas here. So again, this is the standard form of a parabola. Now this one is going to be something we've seen before. This, even though it's written differently, this is really just y and equals x squared. Now we've got this 4p term, but my point is this is going to create a parabola that opens upward. Now, if it turns out that the value of p here is a negative, it would create this entire side to be negative, and it'll be similar to what we saw before. That would turn it upside down. Now, this top formula, we haven't seen it like this before. We have the y being squared. Normally, we had the x being squared. Here we have the y being squared. Now, if the y is being squared, we're going to be moving horizontally. We're going to open to the right. And if that p turns out to be negative, then we're going to have our parabola going to the left. Okay, now the focus, we have a line here and this point. This line here is called the directrix, and this point is the focus. We've seen a focus before, but the idea is this line and this point. The parabola is always exactly the same distance away from this focus and this directrix. So we're going to find all of these. I wouldn't need you to graph the directrix. That's hard to say. But I don't know. I don't think I'd count that wrong if you didn't have it, but we're going to find them all. So let's just talk through. So we have these two versions again. This one on the bottom is going to be very similar to what we saw before, where we're opening either up or down. The one on the top, now with this y squared, is going to be opening right or left. Now the focus, so let's go back down to this one. If we're opening right or left, or no, up or down, sorry, this bottom one is up or down, we're doing everything vertically. So the focus is going to be vertical, and the value of this p is that it tells us everything we need to know to graph it. And so the focus is going to be 0p, because we're doing vertically, so that value of p is going to go up vertically. The directrix then is going to also be based on moving up and down. It's going to create the line y is negative p, so it goes in the opposite direction we did to build the focus. Now, if we're going right and left, then obviously we're moving horizontally, and so that's this top line. So the focus, the value of p, is going to be going right or left, depending on the sign. And then we have the directrix here. Now it'll make more sense. Let me just talk you through it. The last thing, it's with some examples. Let me show you this one lastly. So if we are on the y-axis, so we were opening, if we've got the bottom equation, we're opening up and down, then we know that we've moved p down or up. So p is moving us up or down. And then it turns out that these two key points that we need to help us graph it are always going to be plus or minus 2p. So by knowing this standard form, we have everything that we need to graph it. Let me just dive in and show you some. It'll make more sense if I talk you through one. So we have y equals 24x. Now, we are used to, remember, y equals x squared opens up or down. Well, this is the y squared equals the x. So we're going right or left. Now, so on this one, if this is positive, we open up. If we're going right and left and we're positive, we're opening right. So talk you through it again. Y equals x squared. We know either opens up if it's positive, down if it's negative. We've reversed it. Now y squared equals the x. So we're going right and left, and because it's positive, it's going to open to the right. Now we need the value of p. Well, the way this equation works is 4p equals whatever that number is in front of the x. It equals 24. So p is going to be 6. Okay, so now we have p, and this will give us everything we need. Now we're going right and left, so let's find the, I lost my pen, where is it? Okay, we're going right and left, so let's do the value of the focus. So we're moving right and left, so the focus has moved to the right p values. So 6, 0. The directrix is a line that uses p to go in the other direction. So it is the line, we want a vertical line here. So that is an x line, and it equals -6 because we came back. So one more time, y squared told me, and it's positive, told me I'm going right. 4p equal to this number finds that value of p. Turned out to be 6. Now this is all happening horizontally, right and left. So I know I'm using that p to go 6 spaces to the right to find the focus. My directrix is going to go 6 paces in the opposite direction and be a line. Now the only thing left we need is the lattice rectum points that we can use to define the graph. Okay, so those are always going to be right in line with the focus. So they're going to be 6. And then it's going to be plus or minus 2p to find the other 2 points. So we're going to have 12, and the other one is going to be 6, -12. So when I'm thinking of this, I'm thinking about the direction to help me know where am I going, right or left. So I'm going right, and that these points are along a line from the focus. So that value of x is going to stay the same, so it's p. And the value of the 2 points on the curve are always 2p. If p was 6, I get 12. And we take the positive one and the negative. Let me work some more of these to help you see here. Here's our picture. I thought I put that over on the side, but that matches our idea here. Let's do another one. Okay, so let's talk through this here. Y is -16x. So the first thing I see is this is y squared. So this is opening right or left. But this time, this is negative. So I'm not going to open right. I'm going to open left because it's negative. Now, we need to find the value of p, and it's always 4p equals whatever's in front of the x. So p is -4. Okay, so I've got the value of p, so we can find everything we need. The value of the focus. Now, we're moving right and left. So the focus is going to be over here to the left. We're moving horizontally, so it's going to be on the x, -4, 0. Now the directrix. Okay, the directrix moves in the opposite direction, and it's a line. So if we're moving the opposite direction, we're going to create a line that's going to be an x line. X is 4. Okay, now we need the endpoints. So the endpoints are going to be this point right here and right here. So it's at the same point as the focus, so it's -4, and then it's 2p. So if p was -4, we're going to have -8 is one of them. So it's plus or minus 2p are the two values. So 2p is -8, and then the other one changes signs. Now let me show you a picture here. So here's everything we said. Here's our directrix. Here's our focus. Here are our endpoints. Connect them all, and we've got it. Okay, let's do a couple more of these. Let me keep talking you through them so you understand. Now look what we have here. This is the traditional form. I have y and I've got an x squared. So this is opening either up or down. Now because the value is negative, I am going to be opening downward. Okay, so let's find the value of p. So remember 4p equals this number right here. So p is going to be negative 6 over 4 or negative 3 halves. Now we can find everything else we need. Okay, we're going vertically this time. So what's going to change on the focus is not going to be the x value, it's going to be the y value. So this value of p is going to take us down because we're upside down. So our focus is 0, negative 3 halves. We're heading down this time. And it's all happening vertically. So our directrix is also happening vertically, so it must be a line up here. And that in a line here is going to be a horizontal line. It's going to be y. So are you following the change? Now we're happening vertically. And so all the focus, the values of p are affecting vertical changes. So they're y changes. Okay, let's find the endpoints. So now this is going to change as well. So the focus, so we're moving vertically. So the endpoints are going to be built off the focus. So they're going to be down here at negative 3 halves y. They're going to be down here. Now the values of the endpoints are 2p. So I have 2 or plus or minus 2p. So I get negative 3 and positive 3. So I have an endpoint at 3. So we're down at 3 halves. We'd have an endpoint over here at positive 3. We'd have one here at negative 3. I did a bad job of writing over that. But so here's all the points we need. That's the value of the standard form. It tells us everything we need. We have the focus, the directrix, the 2 points we needed. Okay, if you think you have it, pause it and try this on your own. But I'm going to go ahead and get started. So I see x squared and y. So this is our typical form. This is what we already know. So this is going to open. This is all going to be happening vertically. So and it's positive. So we're going to be opening upward, just like we always did when we first learned about this. Now we need 4p equals 8. So this value in front of the y is what 4p equals. So p must be 2. Okay, so let's find the focus. So it's happening vertically, and p is 2. So we're moving up in the y direction. Okay, now if we take a look at the directrix, that's going to be a line going in the other direction. This is going to be a horizontal line. Those are y lines. I shouldn't have done that. Those are y lines. It's going to be a line at y is negative 2. P is going to go from the origin in the other direction, and it's going to be a line. So that's a y line. Y is negative 2. Now let's put our endpoints on here. Now the endpoints are off the focus. So the focus is up here. Those are those 2 key points. So I know that it's off the focus, so it's going to be happening at y is 2. Now what are the other 2 points? Remember, it's plus or minus 2p. So I've got plus or minus 2 times 2. So plus or minus 4. So I've got a point here at 4. And I've got a point here at negative 4. Okay, now we can just graph it. I'll use their graph down here. Yeah, I don't know what they've done here to shift this. I don't know what they're doing here. This isn't the right equation. They're doing something different, so we'll just go with mine here. Yeah, all their values are the same, but I don't know why they converted it to a more traditional form. I don't know what they're doing with that. Okay, so our last thing here is we're going to be asked to find the standard form based on some information about the focus and the directrix. It's actually pretty easy. So let's first of all find what direction all the action is happening with. If the focus is over here, so here's my axis, the focus is over here, the directrix is over here, everything is happening horizontally. So when everything's happening horizontally, it's y squared equals px. This is not the traditional form. It's going right and left instead of up and down. Now, the value of p, when we look at the directrix, the value of p is -1/2. So from there to the focus is the value of p. So p is -1/2. Okay, so what do we have? We've got the value of p, and we know in the equation here, this is always 4p. Yeah, I should have written it like this. This is what our equation always is, 4p. So if we know p, we can find this, 4 times -1/2. So the number that goes in front of the y is -2. So I've got y squared equals -2x. Okay, if you're following that, pause it, but if not, you want to see me do another one, let's go for it here. So everything is happening here vertically. Do you see I'm going up in the y and down in the y? So I'm going up in the y, and then my directrix is down in the y. So if I went up for the focus, this is going to be a curve going this way. So I've got our traditional, I forget how to do this. So we're going up and down. So this is our traditional view, x squared and y. This is how we first learned it. We're going up. Now our value of p is 7/2 because that's the distance to the focus. So p is 7/2. So to put this number in front of y, we need 4 times 7/2. So that's going to be 14. Cancel down, 2 times 7 is 14. So x squared equals 14y. And that's all we need to do. Okay, now I know this is different, especially when we've already learned quadratic equations, but once you get the hang of it, it's actually pretty simple. So the key idea is just know where you're, whether you're moving horizontally or vertically, and then you know which formula you need to pick. And then once you know which formula you need to pick, just remember the focus is going to help you. The value of p will help you find the focus and help you know whether you're going up or down, or right or left.